That's it. Good afternoon, everyone. Welcome to the Tech Hub. This afternoon we're going to continue our series of technology awareness sessions. We've got Jamie Gibbs, who's an architect here on the HMRC account. He's going to give an overview of cloud. Over to you.
Okay, afternoon everyone. So just to sort of quickly skim through what we're going to go through in this session. I must admit, I'm not a seasoned presenter, you'll probably be able to tell as we get going, but what I want to cover is just defining cloud, so the difference between software as a service, platform as a service, and infrastructure as a service. A little bit of an introduction into AWS. It's the area where I work predominantly. Talk about some core concepts, some of the AWS sort of building blocks. We'll jump into a couple of demos, deploying some instances, technology permitting. Talk a little bit about architecting AWS and DevOps culture as well as managing projects on AWS. So what I've tried to do is sort of put together a review of the sort of differences between the sort of key terms and the sort of traditional sort of layers. Sorry, a bit nervous. Of all the sort of different sort of bits of IT, as it were. Everything from sort of the physical environment, so things like your data centers, power, cooling, things like connectivity, network connectivity, networking within the facilities, storage to support the applications you want to run, compute, hypervisor, server operating systems, database and tooling. Yeah.
There's a number of models. So you could go to a cloud provider and buy what's called infrastructure as a service. I would like a server. I would like some storage. I would like some networking. I'd like you to connect your private data center to AWS, that sort of thing. And then on top of that, you can do the rest of the work. Yeah, so you can put on your own operating system, you can put on your own database, put your own tooling, write your own application, that whole gamut. So that's one choice you have. You can go to AWS or Azure and buy infrastructure as a service. You can go one stage further and buy sort of platform as a service. So I would like a development environment. I would like a set of databases. I'd like Oracle. I'd like Atlassian tooling. So you can buy that. Or you can go the whole hog and say, I want software as a service. I'd like SAP. I'd like Oracle Financials. I'd like, effectively, to buy an application, just host it on the internet. That makes sense? So you can effectively...
So if you put it in the context of sort of those old school types where the likes of FastP were first landed, how would those fit into each one of those?
So FastP, you effectively...
More infrastructure, is it?
It is, isn't it? Because, well, actually, it's sort of... Well, FastP you can buy into a database, can't you? Probably can't go above there, can you? You could say, I want a Windows OS, I want Oracle. And you sort of up to there, aren't you? Yeah. That would be where we would get to. So that's the basic idea. The sort of service you can buy from a cloud provider. The sorts of things you can buy, as an example. So Office 365 would be considered software as a service, or Salesforce or Slack. All those sorts of things we're used to using, aren't we, as bits of software on the cloud. If you go down a bit more, so platform as a service, lots of services. So the cloud market is, heavily, very full of services that you can buy. So IBM have their own cloud, IBM Bluemix. There is an open source sort of platform as a service offering that you can buy and put on your infrastructure. Heroku, those in the DEDCT, when they develop prototypes, they use a Heroku service to host those prototypes for people to do testing. So quite a lot of PaaS offerings where you can go to a cloud provider and say, you know, that's what I'd like. I'd like, I don't want the whole application, I want parts of an application. Right, so you've probably seen these Gartner sorts of descriptions of who plays in this space. You're probably all very familiar with Amazon Web Services, Microsoft Azure, Google, the cloud presence, but not quite in that league. Lots of other people. Our friends Fujitsu, obviously there's an Oracle Cloud. Fujitsu not being visionaries, I find that difficult to believe, but Rackspace you might have heard of, they play quite heavily in the UK government space. So lots of different cloud providers. We're very familiar with this one, not so much that one. We've done a little bit in Oracle Cloud. Alibaba Cloud, this is, if you've ever bought anything from Alibaba, that's a very large Chinese, a bit like Amazon in China, effectively. They have a big cloud presence. You'll see that probably move over here eventually. IBM Cloud, haven't really done so much with them. Right, so let's talk about how we pay for stuff on the cloud. So you can buy infrastructure as a service, you can buy platform as a service, you can buy a software application as a service. If you look at the economics of it, effectively, if you go to AWS and say, I would like some processing power, so a server, so now you're going for infrastructure as a service, you effectively have this idea of sizes of machines, so you can buy yourself a nano machine or a micro machine, all the way up to a very large server. They have different amounts of CPU, different amounts of memory, and different requirements. So if you wanted to host a database, then you'd probably be talking about these larger machines with significant I/O, input-output effectively. So down here you'd be talking about buying pretty significant, pretty meaty processing power. At the top, you're talking about fairly small processing power. You can see the sorts of fractions of cents that we're talking. Per hour? Yeah, per hour. Yeah. So $0.0066 per hour for a small, a nano, a one CPU, half a gigabyte, low I/O machine. So we're all very familiar, utility type pricing, pay for what you use. You can reserve capacity to get a better discount. That's like bulk buying. I want 6 servers and I want them for a period of time. So effectively you get a price for a group of servers for a period. Tiered pricing?
So the more you use, AWS have sort of various sort of thresholds. The more you use in terms of sort of compute capacity and also for storage or data transfer, the actual unit cost of that drops down.
Yeah.
What's the definition of use in that context? Is it physically operating, or is it built to particular spec, or what's the efficiently using that?
So it varies depending on what it is you're using. So the different machine sizes will have different sizes. Likewise, AWS make charges for data that you transfer out of the AWS cloud. Likewise, if you're transferring data between regions or across availability zones, there are small charges that incrementally add up. Also, things like data storage, depending on the type of data storage you're using, you can either get charged for having, say, a 100 gig disk attached to a machine, or if you're using something like object storage, the more you stick into the object storage, you start getting charged when those objects go in, and charges reduce when you start taking some objects out.
But essentially, you get charged as soon as you ask for the server, don't you? Correct. Yeah, as soon as you say, I would like a nano server, you get charged. Whether you're using it to run anything is your problem. They are charging you for having it, effectively.
Correct.
Yeah.
They're saying you have to tell them they're not using it to relinquish that charge.
Say again.
To tell them that you don't want it to relinquish the charge.
Correct. Yeah, so when you fire up one of these machines, you can actually shut it down and have it still exist within AWS if you like. At that point, you're not paying for the run charge. What you are paying for is the storage of things like the operating system disk that's attached to it. Yeah. When it's running, you're paying for the full usage charge, and that's done automatically in AWS.
Okay.
Yeah, perfect. Cost optimization. Well, cost optimization, as I understand it, is quite a big thing, isn't it? There are now companies who will, help you understand the cost models, as Jamie's described. There's costing associated with running the server, with the storage, with transferring data in and out. There is different costs as you go up and down the scale. So if you like, optimizing your infrastructure to get a good cost is quite a black art, to be honest. Yeah.
When you get your bill from AWS at the end of the month, there are some tools on their website that give you some charts and things that you can look at. It's all very broad brush. If you want the detailed, they send you a massive CSV file which you'll open in Excel, and it means nothing. It's been quite a big, as Les mentioned, it's been a good opportunity for some companies to come in and help clarify some of that by using third-party SaaS offerings to plug into your code and actually do a breakdown of what's going on. Things like cost optimization. If you transfer data less, obviously you get paid for transferring data across boundaries. So if you group things together, you can reduce costs. Going back to reserved instances, if you've got a stable workload, lucky you, you can say I need this many servers and I'm going to contract a year up in advance or 3 years up in advance with AWS to get discounts. If you've got quite a spiky workload, and we've just gone through SA Peak, what you can do is commit to a certain amount of core functionality that you want to use, and then reserve that, and then pay for incrementally just for how much you want to expand that, and then that shuts down afterwards. So there's, it is a black art, and lots of different options.
Okay.
What I'll cover off real quick.
Okay. So this is looking at a history of AWS. Obviously, they are growing all the time. I listen to podcasts quite often, and I listen to the AWS podcast at least once a week as I drive in, and every single week there's more and more functionality, more and more locations. They're spreading around the world quite freely. Do you want to take us through this, Jamie?
Yeah. Thanks, Les.
Are you all right?
Yes, I think I'm getting into it.
That lens is beginning to kick in, I think.
So the foundations of AWS were actually laid in 2002 with a white paper that was written for some of their engineering staff. That was the first suggestion that they could actually sell this computing power they want to do. The main purpose of the white paper was talking about abstracting Amazon's retail operations from physical hardware and physical infrastructure they were using at the time. It wasn't until 2005, actually 2006, they did a public launch. It was actually in beta to a few of their customers. The main purpose of this was selling compute power to those people who wanted leverage power of Amazon's retail operations as well. But that grew, people started using it for all sorts of things which possibly weren't related to Amazon. Hence that drove the creation of a number of different locations. So 2008. Our first European region, which was Ireland, was introduced. A whole gamut of new services. 2016 was a good year for us because we got the London region. At the time of writing, so we've got 16 regions across the world, each region with multiple what we call availability zones, and over 100 sort of separate AWS products and services through AWS.
What are they? So for S3, SQS, EC2, what are they?
So they're AWS products. I'll take you through just in a little bit more detail in a couple of slides' time. But S3 is a storage technology. SQS is to do with something called queuing, and EC2 is this sort of virtual machine compute unit, if you like. AWS refer to it as an instance. Talk about some key terminology. If you've got an account on Amazon.com or Amazon.co.uk, you've got an account that you can use with AWS. And into that, you can go into AWS, you could set it up, you can go and sort of deploy yourself a server. If you want to, you can go and deploy yourself quite a lot of servers. Typically, when we're sort of looking at this in a commercial sense, you would set up multiple accounts. So AWS have something called the multiple account security strategy. So what they suggest is you have one account, you stick all of your users in, all your sort of permissions to be able to use the service, and then you set up different AWS accounts for the individual environments. So one for dev, one for QA, one for tests, one for production, maybe multiple ones for production if you want to be able to switch between them. Regions we touched upon briefly in the previous slide. So these are sort of international locations around the world where AWS have data centers that host these applications. There's a whole load of things that AWS call endpoints. So one of the products they offer, for example, is something called CloudFront, which is to do with distribution of web content. Now, they've got hundreds of locations with major ISPs across the world, but not to be confused with the actual regions, which is where the services live, as it were, or where you can run your services if you wanted to. So availability zones are probably akin to a physical data center. So recall I mentioned that we had London was launched about a year and a half ago. Whenever AWS launch a new region, they launch it with at least 2 data centers, and each one of those data centers is what they call an availability zone. So what AWS have done, the data centers are physically in different locations for resiliency purposes. So the idea, and something we'll cover in a later slide, is that to make your applications more durable, more highly available, is you would actually sort of split your infrastructure and use multiple availability zones to physically have your computing and other services in multiple places.
It's a bit like Fujitsu having SDC01 and SDC02.
Did you have to actually specify what this availability zone happened, not just by saying, I want this region, you automatically assigns resiliency?
So when we go into the console, I'll show you, but you basically operate within a region, and all of the availability zones that are available within that region are available for you to deploy into. So depending on how you want to deploy the application will depend on sort of whether you use 1, 2, 3 availability zones. Some of the US ones I think have got 5 is the most.
Dev, you might just say, I want to develop this environment, I only want it in one availability zone, because I'm not bothered about effectively having it highly available. But obviously for live, then you might say, I want that split across 2 availability zones. So that choice of which services and which availability zones, which regions and which availability zones is the choice you make.
And presumably, how much you pay for the service one.
Yeah, so you'll pay, one of the obvious ones is you pay data transfer fees for transferring data across availability zones. So it does affect how you would architect a solution. Read any sort of documentation provided by AWS, and you'll be reading about elastic this, elastic that, elasticity, and auto scaling. This is the concept that if you have a service running on an individual server, that server lives in an availability zone. Say you needed to sort of scale up performance of that server, you could deploy another server, another server, and another server. And this can be done automatically. It's using sort of several different technologies within AWS. to be able to sort of automatically expand and contract. And this feeds partly into the sort of cost optimization model that we spoke about earlier. So AWS managed services. So as well as the sort of building blocks which we'll go through, AWS provide a number of services. It's almost like a SaaS offering whereby they'll manage all of it for you. So if you think about things like databases, they provide a service called RDS, which provides you a database, and there's a variety of different engines. I've got something in the following slide. And they will manage the actual sort of database server itself. So all you need to worry about is getting your data into the server, out of the server, and doing what you need to do with it. But they will manage the sort of full stack under that. Broadly speaking, there's two sorts of services that AWS offer. They've offered quite a few sort of proprietary services. So things like their email service, their queuing service, notification service, which are proprietary to AWS. Typically, you'd access them by a web API. So if you wanted to integrate your code with them, you would have to sort of write an API interface to be able to talk to it. And AWS provides you the tools to do that. The other services are things like the database service, whereby they effectively mimic a database service. So if we wanted to deploy a MySQL database server, for example, we could use RDS to do that, and our application wouldn't realize that it wasn't actually a MySQL database server because it's fully compatible. So there's two types of service. Something that's quite big, so I do a lot of work with HMRC. They're keen not to be sort of too reliant on a single vendor in terms of cloud providers. So they are looking at, although they are pretty much all in with AWS, bar a few things, they are also looking at Azure. So one of the sort of things that they were looking at was keeping whatever solutions are developed to work on the cloud vendor agnostic. It's easier said than done. Not all cloud providers have been created equal. There's a lot of functionality which might exist in one provider which is not available in another provider. Also, the rate of change in terms of how quickly they're developing these services, there's a big difference.
So are people moving towards sort of multi-cloud where they might use Azure and AWS to host a service, and then they can sort of mix and match a little bit? Is that...
I think they'd like to. There are a couple of products available on the market that allow you, effectively, you do your orchestration into this product. So Cisco Cloud Orchestrator is probably the main one. That will then go and talk to AWS and Azure, but it's very, very high level. Because you haven't quite got the same services available in one provider and another, you've got quite a limited subset of features that they'll let you use at that level. Technically, you can do it. It's quite a lot of effort. So there's a number of tools which we use for sort of orchestrating on AWS. Again, it's going to come up in a following slide. Whereby you'd use the same tool to orchestrate on both, but the way that you'd write your code in order to implement it for AWS would be different to the way that you would write your code to be able to implement it in Azure, for example. So although the skills, so if you've got sort of like Terraform skills and that's the tool you want to use, you could use your skills to develop both sets of functionality to bring you up to a certain sort of horizon, as it were. It's quite a lot of effort to keep everything in parity, if you like.
Is that the sort of future direction we're going in towards, and that some of those complexities will be made easier, as it were?
We haven't really seen much evidence of that so far. AWS seem pretty intent on sort of blazing the course that they're going in, and Microsoft is sort of going in a slightly different direction. Yeah. Microsoft have obviously got a lot of sort of tools and integrations with their existing sort of service stack. Obviously, there's still lots and lots of people who are using sort of Microsoft Windows, things like SQL Server, SharePoint, Dynamics CRM, all that good stuff, where they provide quite a handy bridge into Azure, but that would never work with AWS.
So this idea that you can switch from one cloud provider to another seamlessly, or at least follow the money, follow the cheapest price. That idea is quite as easy as it sounds.
It's one of those things, cloud computing, that's referred to as it's one of those things that people talk about a lot, in practice. It's unlikely that will be supported by these big vendors. I think when HMRC were using small UK-based cloud providers like UK Cloud or data centers, that's different because HMRC are big customers to people like that. They're not a big customer to people like AWS or Microsoft, really. And AWS will do what they do. If you end up with one system spread across AWS and Azure, then you'll pay a lot of money because you'll be transferring data from one cloud provider to another, and they'll charge you for that. You'll have processing in both places, and they'll charge you for that. And your optimization will be difficult because you won't know quite how to optimize. If you optimize for AWS costing, it might cost you more in Azure. So it's one of those things I've talked about a lot. At this scale, when you're on things like AWS, I'm not sure it's really necessary because this stuff works and it is highly available. So whether it's necessary, I don't really know, but it is one of those things I've talked about a lot. I don't think it will really happen. I think that's a little bit different to not being tied in completely. So you might want to choose, not to use AWS specific services. So you can move, but the idea of having it in both places at once and running in both places at once, I think is not where we are today. It might come, but it's not where we are today.
So if you were holding in one, say AWS, and you want to move across to Azure because you thought it was cheaper.
Yeah. And it would be a data migration almost effectively.
Right.
And for example, if you had your data in MySQL, then both of those vendors will give you a MySQL database. So that would just be a matter of plugging your data out of MySQL, moving it across to Azure, starting up their MySQL implementation, running your application. If you had it in a AWS proprietary database, then you're struggling because now you're into a data migration from one sort of database to another, and changing data types and changing data potentially. So that's much more complicated. So there is a common denominator in these areas, and I think probably most people stick to that if they want portability. That's not the same as saying we're going to have my application split across two cloud providers, run it real time across two cloud providers. I think that's a way up. I'm not sure whether that happens.
Yeah, there's two main reasons why people sort of take that view. Government providers, obviously there's a political element. If a provider doesn't pay their tax, for example, they want to be seen not to be necessarily carrying on in a similar sort of relationship. The other one, which is probably more applicable to sort of private customers, is availability. You've got so many options in terms of high availability in AWS and also in Azure that sort of mitigate a lot of the sort of main use cases. There have been some high-profile outages for both AWS and Azure, but you can still count them, I think, on two hands, going back sort of 6 or 7 years, where there's been anything that's been majorly service affecting for more than a few hours. So in terms of availability, making, as Les says, trying to split your system to run active-active across two providers, whoever they are, introduces so much more complexity that the likelihood of something going wrong is greater.
You talked about licenses at all, and the implications of licenses. Is that just something else that just adds more complexity?
Yeah, we can. I cover it a little bit in a couple of different slides here. So I'll run through that, and we can talk about sort of specific use cases if that's something that you're interested in looking at. So, but yeah, it is quite a big talking point, and it's one that's been sort of going on for quite a while. So, but there's a lot you can do from a sort of an engineering perspective. A lot of the code that we have written on the project that I'm working on is all modular. So we've got sort of naming strategies. All of our code is modularized and parameterized. So although we might have to adapt some bits of the code to work in AWS or some bits of the code to work in Azure, once we get up to a certain level, I'll talk a little bit about containerization later. The actual above that level, we could actually move bits of workload from one platform to the other. So I'm just going to very, very quickly sort of go through sort of some of the building blocks. So EC2, or Elastic Compute Cloud, to give it its full name. AWS certainly refers to it as an instance. Over in Azure, it's referred to as a virtual machine, which probably more closely aligns with things of the sort of VMware world. As Les pointed out in the slide about pricing, there's a number of different types and sizes. So depending on what sort of workload you want to run, whether it's basic application running on Windows or Linux, or whether you've got something that needs a huge amount of memory, so SAP HANA, for example. Whether you've got something that's high I/O, so you're running something like maybe a logging solution that's got a huge amount of very small transactions running against it. There's different classes of machines, and then those machines are also available in different sizes. So how many CPUs do you want? How much memory do you want? Some machines are available with storage built in. For any machine that doesn't have storage built in, you've got something called EBS, which is a way of sort of adding storage to it. AWS are exclusively Intel-based, which was threading with the recent meltdown and Spectre patches. Officially, they only support Windows or Linux, and there's a variety of different sort of Linux vendors. And a few different versions of Windows going back. Technically speaking, there are some backdoors. I've actually had BSD running on AWS, but it's not supported, but it will work. Also, you can buy sort of pre-configured appliances from something called the AWS Marketplace, which are sort of pre-vendor packaged firewalls, sort of bundle packages of applications, etc., which are pre-configured. Some of those, some of the Cisco stuff, for example, I think it's Solaris underneath. So, but I guess Cisco will be supporting that. So again, just going back to the pricing briefly. So the pricing that you'll see on there's something called the Simple Monthly Calculator on AWS. You can go in and have a look at all of their pricing. It's always traditionally been priced by the hour. And up until I think late last year, if you ran a machine for 1 minute or 59 minutes, you were still charged for the hour. It's now charged by the second, which is quite a big advantage for people, especially if they're just spinning up an instance to go and do some work and taking it down again. Very good for me and my AWS account, where I'm constantly sort of spinning up and doing demos, etc. So we spoke a little bit earlier about sort of reserving compute capacity. So you can reserve compute capacity. You can get up to 60% discount if you're willing to sign up for I think 12 months. There is a 3-year option which brings the cost down further, but the price of EC2 instances has been falling generally over the past few years, so it's probably not that feasible to reserve for that long, because that computing power will probably be a lot cheaper by the end of the term. So I mentioned AWS Marketplace. A number of vendors, some sort of really quite big names, so people like Cisco. You can buy something called a Cisco Cloud Services Router, or CSR device. Fortinet, Juniper are selling network appliances. You can buy sort of pre-configured Microsoft SQL servers. You can buy just a whole range of sort of different appliances. When you buy something off of the AWS Marketplace, some vendors will say you have to pay them a license fee, so you'll be paying annually for something, maybe quite a few $1,000s, and as soon as you take it out, that's it, you're tied in. Other vendors work with the hourly pricing model, and it can be a good way if you need to spin up a licensed piece of infrastructure. You can go in there, deploy something. You'll be paying a higher rate than the standard EC2 rate, which is just the compute, for the license fee, but it allows you to pay for the license fee by the hour. So I spoke a bit about storage. Let me know if I'm sort of going on a bit too much about some of it. There's lots of different types of storage for different needs, as it were. So EBS, the top one there. Imagine that like a hard drive, or like a volume on a SAN. These are volumes. You can choose how much space you want and attach that to an EC2 instance to work. and give you storage, and you can use that as a boot volume. Thanks, Les. There's also a couple of different sort of performance options with EBS, so you can have sort of high speed sort of SSD based storage, and there's I could probably go on for a couple of hours just about EBS, but there's all sorts of things you can do about touching multiple volumes and using it as like a RAID array, as you might have done sort of in the physical world. AWS also provides a service called EFS, which is like a network-based file system. Again, this is fully managed by them. You sign up for EFS. You don't need to tell them how much you need. They'll give you an endpoint, and you can just store stuff into EFS. And EFS can be connected to by multiple computers, so it's quite good for shared information. It's probably worth noting at this point that not every service is available in every region automatically, so EFS isn't available in London yet. But London got its third availability zone literally just a couple of weeks ago, and we think that now that that's gone, EFS should hopefully follow quite soon afterwards. So S3, I remember who sort of mentioned that. So S3 was one of the sort of pioneering services from AWS, and it's what we call object storage. So you access it via a web call, and you can actually go in and have a look at your S3 storage through a web browser and upload files and download files. It was actually the first service that I used. I used to have one of these sort of network hard drive boxes at home, which you store all your cat photos on, etc. And I used to back it up to S3. So that was the first AWS service that I used. You might have heard the term an AWS bucket. So a bucket is a way of talking about a lot of objects that you've put together in one particular container, if you like. So there are some storage limits. I think it's 5 terabytes for a single file for S3, but otherwise, again, you can just carry on adding and adding and adding and adding. You can store petabytes of information there. Just finally, again, I won't sort of go too much into detail. Glacier is stand in front of the camera. Glacier is an archive service, so this is the cheapest storage that you can get from AWS. So what you can use this for if you want to sort of keep logs long term, or whether you've got sort of accounting information that you need to keep long term. You can archive it off from, say, S3 into Glacier, and you can set up rules. Lifecycle rules to be able to sort of shift data automatically based on how long it's been there. It used to be almost literally like a tape drive service, in terms that if you wanted something back out of Glacier, AWS would say that there's potentially a 24-hour lead time to be able to get that information back out. As of last year, they've announced an expedited service. I think you can get it back within the hour. So it's quite useful, especially if you're looking at storing quite a lot of information. Databases. So we spoke a little bit about sort of managed services, managed databases. So RDS is the relational database service, is Amazon's database as a service offering. So you see a few different sort of icons around the sort of main blue icon there. It's available in a number of different flavors. So if you choose things like MySQL, MariaDB, Postgres, SQL, or Oracle, it effectively mimics a real database. So your application shouldn't be able to sort of tell the difference. There are some caveats, and it very much sort of depends on sort of very specific differences between engines, etc. Amazon Aurora is Amazon's version of MySQL. Amazon claim it's 5 times faster than MySQL. It's generally MySQL compatible. There's a couple of differences in terms of the way it sort of handles users and security, but Amazon have priced it competitively to get people using it.
That would be an example of a AWS proprietary service. If you were to go down that route of that's really well priced, I'm going to put all my data in Amazon Aurora, then move to a different cloud, then although it's MySQL compatible, you might have an issue. Whereas if you put your data in MySQL on there, then you should be able to move it between cloud providers without too much difficulty.
So AWS also provides a service called DynamoDB, which is a NoSQL or non-relational database, again, which is proprietary to AWS. So those are sort of like as a service options. Again, we were talking about the sort of pre-configured AMIs that you can get out of the marketplace. AMI being a machine image, as it were. So there's a whole bunch of vendors who have stuck their database offerings in as a sort of pre-configured option that you can just pull down, download, and run in your environment. For anything that isn't available as an AMI, or if you wanted to deploy your own, AWS work with quite a lot of vendors as well to provide architectural patterns. So if you wanted to run something which is a little bit sort of left of centre, say like Couchbase or MongoDB, there are sort of architectural patterns for deploying into AWS. I thought I'd stick this in. I came from a networking background years ago. I promise not to sort of labour the point too much because it can get quite tedious and in depth. You may well have heard of things like VPC, Virtual Private Cloud. So this effectively is the name that AWS gives to a whole sort of bunch of networking, and it's a networking environment that you can sort of deploy into a region, and you can span multiple availability zones, and that's where you stick your compute resources into. I promise I won't go any sort of further into that.
And it's the mechanism to separate you from other people.
Yes.
So if you're in a multi-client cloud like AWS, effectively your virtual private cloud is yours. Nobody else has access to it. It's the way you separate yourself.
Yeah. So Direct Connect. So AWS work with a number of sort of ISPs to provide network connectivity into AWS. If you don't want to just go across the internet or set up a VPN, you can sign up. This is usually a contract because it's the ISPs will be putting in connections for people. There's a few in the UK, hundreds across the world. We could sign up with somebody like BT. BT would run us into something like Equinix or Telehouse North. From there, connect directly into AWS. The main sort of driver for that is if people need guaranteed bandwidth and they need sort of low latency connections. So especially, particular use case might be if you're working in a hybrid mode and you've got on-premises systems that need to talk to systems you've got deployed into AWS, you might want to consider Direct Connect.
Am I right in saying HMRC have done this?
Yes. So there's two lots of AWS going on within HMRC at the moment. So the Cloud Delivery Group have got a number of sort of pre-configured environments that they have connected using Direct Connect, whereby HMRC Digital are a different group of AWS accounts. We're not direct connected yet, but then generally all the workloads run in AWS and they don't have anything running on premises. So Elastic Load Balancing, one of the sort of building blocks, as it were, kind of equivalent to something if you had like an F5 load balancer in the physical world, provides load balancing to route connections across to your instances working within AWS. Particularly useful again if you've got a spiky workload and overnight you've got your running 4 servers and then throughout the day you might be running 16. This will automatically handle the connections, configured correctly, of course, will automatically handle configurations out to those instances. Yeah. So Route 53. Route 53 is AWS's DNS provider. It can be used for a whole host of things. You can use Route 53 on its own if you want to, without using any other AWS services. You can host public DNS records, much the same as you might use someone like Ustar to host DNS. You can also use it internally to host DNS for your internal systems running within AWS. So this provides the name resolution, which is where you take the type of name of the service you want to run, or you want to get to, and that'll go off in the background and return the computer the IP address, so it can take you take you there. VPN options. So AWS provide basic VPN connectivity to something called the Virtual Private Gateway. You just about make it out on the screen there. This allows you to do sort of fixed point-to-point connections between on-premises networks and your virtual private cloud networks in AWS. It works quite well. It's very reliable. It's resilient to faults. It is a little bit limited in terms of there is only a sort of like a subset of routers and VPN parameters that it supports. For everything else, like I said, there's a variety of sort of third-party appliances from the big vendors that can do all sorts of things like securing VPN connections with certificates and all that good stuff. So I promise I won't go any further. One of the big topics, and has been for many years, is security. So AWS introduced something called the shared responsibility model, and basically this is the sort of slogan that goes with it, is that AWS are responsible for the security of cloud. We are responsible for the security in the cloud. So it's a whole bunch, it's a framework, a whole bunch of sort of guidance around sort of securing your data within the cloud using things like encryption, of data at rest, and also secure communications between components as well. AWS have their own sort of user access control system called IAM, which you can use to sort of secure who can access which objects and services within AWS, and this can be really fine-grained down to and letting people have specific control of individual sort of records in some cases. AWS uses something called security groups, which we'll come to when we do the demo in just a second. Imagine that as a sort of like almost like a personal firewall that you can use to surround a computer, and you can configure it to only allow the traffic you want in and the traffic you want out of that instance. So it allows you to isolate systems within AWS. And also AWS provide a few different options for key management. So this is things like encryption keys, etc. So AWS provide a couple of services, one called KMS, which is for storing keys. They also provide something at a greater cost, which is a hardware security manager, so a bit like F5 as well, provide a hardware key management. And again, there are options available within the marketplace if you wanted to use a particular vendor. So, demo time. Sorry, it's not my computer.
You had a Mac, didn't you?
Oh, yeah.
So we just need to click out of. What, just a browser?
Mm-hmm. Please.
Yeah.
There we go. So I'm just going to log into the AWS account. I apologize, I'm using my own account, so. Ooh. Doesn't like your computer, Les. Remember which one this is. Okay. I've got a few AWS accounts, to be fair, I use for different. There we go. AWS also provides the ability to use two-factor authentication, so
They're going to be texting you a code, are they?
I use Google Authenticator, but they can text you a code, they can use Authy or Google Authenticator.
To use AWS if you've got an Amazon, small Amazon account like this.
Yeah. And they have a free tier generally, where you can use quite a few of the AWS services free of charge.
Free, yeah.
And then only when you start doing things at high volume do you basically get charged. So most people in most areas can go in and play with AWS without charge. That's not the same as saying you don't need a credit card to do it, you still do everything.
Yes.
Yeah. They don't charge.
Yes. Yeah. There's some. I won't go into details, but there's something called AWS organizations where you can build a sort of nested hierarchy of different accounts. So you can get around that with that, but that's like a corporate thing as opposed to something for individuals. Mm. So this is the AWS console. So this is the sort of main screen that you get presented with. So this is just the details about your accounts. And this is the region. So these are the regions around the world. You can't see it all. That you can deploy into. So obviously I was in the Ireland region last time I was there. So if I select London, and then you've got tech support.
What would it matter where you deploy it to?
So technically, although all the core services are available in every region. Some services aren't available in every region, but they will probably soon be rolled out into them. HMRC are particularly specific that they don't want anything outside of UK territorial. I don't say territorial waters there. They want
to make sure your data is in the UK and not anywhere else. So if you went and created it in North Virginia, your data would be there.
Oh, okay, so it's physically in.
It is.
Yeah, that's the data center that it'll be running in.
Until recently, EU Ireland was probably the main EU place, but obviously the government were not happy about putting their data outside of the UK, but still in Europe. But now obviously we've got London there, happier to put their data in London.
Does it have any legal implications?
Yes. That very good, yeah, absolutely. If your data is in the US, you are subject to US law.
Yeah.
So that means the government can go look at all your data whenever they like.
So be aware there's a couple of caveats. So things like CloudFront, which is the content delivery network, just by its nature is spread across a number of different regions. Also, I've logged in here. So the IAM solution, that is also deployed across the world, which allows me to go and log into different regions. If I want to spin something up in Tokyo or Sao Paulo, I can go ahead and do that. There is a caveat, which is China. China is a separate AWS region, all of its own.
The Chinese wall.
That's interesting. The regions, isn't it? There's large swathes of the globe that aren't covered.
Yep.
In East Africa.
Yeah, I mean, there is. I did make some notes actually on the PowerPoint. I think they are actually looking at putting one in Joburg. So it's on the list. Hong Kong. I don't know whether that would still be subject to the Chinese arrangement, or whether Hong Kong would be available to other UK users. But yeah. So Azure has a similar footprint. I don't think they're in quite as many different countries yet, but I'm sure that they will be. Likewise, Alibaba Cloud is working its way slowly west, and they've got some good offerings. It's not something that can be ignored.
So if we can only stay in the UK regions, I assume that they have multiple database locations.
Yeah. So we've now got three. A couple of weeks ago, the third one came online. So they're badged up as being London. Whether they are actually in London or not, I don't know. One thing is for sure is they won't be close to each other. Yeah. It's anything that we want to deploy, we'd stick in London. So each availability zone is a disparate data center or a couple of data centers in a similar location. And that Amazon have their own sort of dark fiber connecting these locations up. So if you've got a system that's in one availability zone and needs to talk to a system in another availability zone, it'd be sort of sub-millisecond communication between them.
So we've got multiple data centers in the UK as well.
Yes, you don't have control of where you put things. I think it takes care of sort of making sure it's running in multiple locations in the background. With AWS, it's almost a conscious thing.
But you can choose Great Britain. You can choose.
Yes. So let's have a quick look. So it stores the most recently used services. So these are just some of the services. Like I say, over 100 as of December. So everything to do with computer storage, database that we covered, migration, content delivery and networking, tools for developing software, security stuff, analytics, something that was very, very big. Last year there was a number of sort of new analytics services announced within AWS. Internet of Things and machine learning have been very big things this year with a number of new services from AWS. I take quite a keen interest in some of the machine learning stuff, so I'll probably run some sessions on that later on. So other services around sort of converting media, things like there's quite a lot of stuff to do with sort of mobile services as well. So
I find this one quite interesting. This device file is more or less every single mobile phone, isn't it?
Yeah.
So if you want to test your mobile app on hundreds of different phones, effectively you can do that on Amazon. You can say, here's my app, please run it across all these phones, and basically you get pictures of it physically running on all those phones. We've got a big farm of connected mobile phones, which is quite neat.
Yeah, I mean, I came from doing a project for DVSA before I came to Capgemini, and this had been announced just after they bought a whole load of iPhones and iPads to do testing of the new MOT service on those devices as well. So very, very powerful to be able to do it all here. So I was going to deploy a server. How are we doing? Okay for time?
Yeah.
Yeah. So what we'll do to save a little bit of time, I'll use my existing VPC. The setup happens to be the default one. In this account.
So VPC is effectively your bit of the cloud, Jamie's bit of the cloud in this case, private to him.
Yep. So I've already got some networks created in my VPC. Public 2A, which is in the 2A availability zone, and 2B, which is in the other 2B availability zone. So let's deploy an instance.
When you say it's private to Jamie, that implies that anything else you do isn't private then?
Well, you're in a public cloud, aren't you?
Yeah, but with your own account, I would have thought you're doing something private with your own account.
So there's a couple of different. So the VPC came along a few years ago. It used to be that if you wanted an EC2 instance on AWS, it was called EC2 Classic, and you spun it up, and it had a public IP address, and you could access it straight off the internet because every EC2 instance you deployed had its own public IP address. What VPC allows you to do is you can keep all of those computers inside your VPC and then just connect to them using Bastion or something. So they're not all live on the internet.
To stop people getting onto them.
So I'm just going to launch an instance. So we spoke about machine images before, and there's a whole bunch of sort of blank OS images that you can choose from. So Amazon provide their own version of Linux, which is quite good. You've got SUSE, Red Hat, Ubuntu. You've got a number of different versions of Windows that you can deploy as well. So, but if there's something in particular you want, go off and look. There are literally thousands. And for example, with CentOS, you've got different versions as well. So
this is you basically saying, I want a server, and here's a big list of operating systems that you can effectively load onto. Similar to going to Fujitsu and saying, please give me a server with whatever Red Hat on it. Apart from this, you get it.
So you notice we're deploying So we're deploying an open source operating system here, so there's no software charged. That's the run cost of running that instance. If we go for something different like Windows, for example, you'll see that there's a license cost associated with it. So remember we talked about all the sort of different sizes you could have. So depending on sort of how much processing power you think you need, how much memory you need, what sort of I/O you require, you can choose the one you want to use.
You would have had to do capacity management and say exactly what we want. Here, you can effectively guess, and then change it if it's wrong. So we think we need one of these. Run it for a while. Oh, actually, we need a larger one.
Absolutely. Some types of instance, I don't think the T's, because they're sort of legacy, say legacy processors, they're the previous generation processors. I think anything from sort of them onwards, you can actually shut it down, resize it, fire it back up again. If you wanted to do that on the T size instances, because we're going to use a hard drive, an EBS volume that we can detach, you could shut it down, detach the volume, spin up a new larger volume, plug that EBS in, and it boots up. Exactly the same way. So I'm just going to deploy T2. You can deploy lots if you want to, but it's not a good idea. So choose what network you wanted to go into, as in which VPC. Which availability zone, if you want to nail it to a particular one, or you can just let AWS choose. Stick it in A. Because the subnet I've selected there is one that's actually connected to the internet, I can actually make it accessible from the internet and give it its own public IP address. So I'll do that just for the purposes of the demo. So you've got the option. Am I going into too much detail here? Possibly. You've got the option to whether, if you want to, say if you want to shut something down overnight, you can set it so that once you shut it down, it terminates, and once it terminates, it's gone. So I'll just say, just stop it, don't terminate it.
In your dev environment, for example, you might want to turn off overnight because you're not actually going to use it.
Mm-hmm. Save significant costs.
The storage, so in which case you want to stop it as opposed to terminate it. Mm-hmm.
You can protect it against being accidentally. This is effectively adding an "Are you sure?" option to deleting it. We can enable detailed monitoring, so per minute monitoring as per 5 minute monitoring. We can run it on a dedicated host within the AWS data center, but that increases the costs quite a bit. So the sort of default there is to run on shared hardware. Just have one network address. It's going to have a single 8 gig volume. I push the boat out and have general purpose SSD. That's the number of IOPS. You can, on some volumes, you can actually increase that as well. So
that's IOs per second. So if you have a database server, you need quite a lot of I/O throughput effectively.
Finally, things you can add tags, which is very good once you get sort of into the realms of tens or even hundreds of servers to be able to keep a track.
Is part of my development environment or part of environment as a way of tagging things so you could get costs for individual groups of things effectively.
So we'll just create a new security group. Oops. So this is this sort of personal firewall, if you like. So this is a set of sort of network rules that go with your instance that show what you can connect to it on. So Secure Shell is just a way of connecting to Linux instances to get to the console. And what I've done is I've limited that to AWS can tell what your external public IP address is. So I did that in as the source there. And we will launch. So this is just a summary of everything we've done. I won't connect to this, so what I'll do, I'll just use the key that I created on the machine. Takes a second. It does vary depending on times of the day, on sort of how long things take to launch.
Is there someone around behind the scenes patching here?
There have been a couple of scenarios. When the London region was new, there were a couple of times when they'd run out of particular instance sizes. I think because it was a new region, but they seem to have got past that now.
So that's the equivalent of a few years ago of going to Fujitsu saying I want a server, please buy me one, please wire it in, please put an operating system on it, please start it up. That's the modern day equivalent. And of course, Jamie's run through that on the console. That can all be automated by various programming languages. And redone over and over again very quickly. And if it's not the right size, you can make it bigger. A whole host of flexibility you have that you never used to have. And now you basically have a running Linux machine in this case.
Yeah, with the connection to the internet, which if we had an SSH client on the machine here, we could SSH into, and it's live. As easy as that.
And similarly, if you wanted a database or any of those sorts of things, you could have. That could have been the creation of a server running a database or a server running a whole host of software. That's how straightforward it is. You still need to obviously know how to design it, and you still need to know how to do networking and all that sort of thing. But fundamentally, it's all now done. It's already wired. It's already there. You're effectively just allocating yourself one. And paying for it.
And spinning up 10 or 100 is just as easy as that, and it all comes up in parallel as well. So it's not like the orchestration is being done from your local machine here. You've sent a command to AWS, and AWS will build out that environment for you.
So all the development that's done on that server belong to you and not nothing belongs to them?
Correct, it's your instance, yeah. So I've lost my notes. So we probably covered off quite a bit the sort of differences between sort of physical cloud infrastructure. How quickly it can be stood up, I guess, is one of the sort of key differences there. We spoke a little bit. going back to sort of legacy deployments, doing this in the past would have meant sort of come up with some specifications of a load of servers. You've then got to engage with the vendors, get the right specs, get the right part numbers. All that stuff's got to be shipped in, stuck into a data center. You've got to hope that your predictions in terms of the scaling were correct, so you don't need to change too much of it. And the deliverable was, the rack of servers in the data centers, all configured, all cabled in. That was the sort of end product. What we're finding now, working in the cloud, is we spend all of our time writing this infrastructure as code. So this is this programmatic instructions that we can fire at AWS to get it to build the exact environment that we need. So the deliverable now isn't actually what's running in AWS. The deliverable is this code. So this is what we've developed for the clients, and that's what we sort of pass to them as a sort of finished product, if you like. We talked a little bit about standardized approach. If you are deploying sort of tens, hundreds of servers, having a sort of things like standardized naming conventions, so you can sort of work out exactly which servers are going where. You can use the same code to build out your dev environment, your QA environment, test and staging environments and production environments the same, so that you have effectively one set of code that you use for deployments, but you just tell it which environment you want it to build, and it'll go off and build them. Within AWS as well, it gives you the ability to, you can split out components and use some AWS services within a particular application. Given that you can size all the individual components quickly, resize them and swap them out as well, you could run sort of different elements of the system on separate EC2 instances, if you like, instead of running everything on one monolithic server that has to be patched, has to be updated, is subject to breaking down, etc. There's a very different philosophy in terms of designing for failure. So where you might have deployed something like a RAID array, very expensive sort of set of disks to make sure that you didn't sort of lose any data, you've now got the ability to spread your data across multiple physical locations, and that's something in the physical world would have cost an absolute fortune to be co-located in different data centers and to have sort of low latency, high bandwidth network connectivity. So there's a very different sort of view in terms of sort of how you would architect to take advantage of that, whilst not needing to necessarily sort of cluster services or to sort of build the equivalent of a RAID array in a single data center. And also security, which I think we talked about a bit before. You can actually sort of build that into the infrastructure as code, so that no mistakes, no mishaps, no accidentally forgetting to configure firewall rules or anything like that. It's all done by code every time in the same way.
Would you really consider the security aspect? If you employ this AWS to host your data, isn't it them that's responsible for losing your...
So do you have to still do like infrastructure vulnerability assessments and things like that? Are they just gone by this, or how does that work?
So probably a couple of different. So we still need to very much do infrastructure assessment. So I've had to do a couple on the project that I'm working on. So it's a shared security model. So AWS will make sure that the services and the tools and the facilities are secure.
So in simple terms for me, for example, if you put a database in AWS with HMRC data on it, as an example, then AWS should say, provided you've secured that appropriately, no other client of AWS should be able to see your data. If we're backing it up for you, we will back it up in a way that nobody else will see your data. So they're making sure that in a public cloud with loads of customers, that your bit is not visible to other customers. But if you took that data, even though no other customer of AWS can see it, if you took that data and made it publicly available to the internet with no controls, then you're wide open. So they are saying, we will make sure that in a public cloud shared by lots of people, you are isolated from other people. But that does not mean that you're secured from the outside world. You still have to do that work to make sure that you're not You're not creating a server with a public IP address that you're then telling somebody and somebody can come into it with no user ID and password and all that stuff.
Okay.
So that's roughly the split there.
Yes.
Yeah, I think that's
But regarding backup and things, when you talk about where you put your data in different physical areas,
Yeah.
I wouldn't have thought you'd need to do that from a user point of view. I thought, well, if you've got your data, if you put it somewhere, then it's up to them to make sure that if you're paying them to make sure that your data is safe as opposed to secure, it's not going to just disappear.
Yeah.
Then that's their job to do it. That isn't it rather than you.
It's definitely their job to ensure the durability of the data. I think the view is that you should assume that if someone could get into your environment, you wouldn't want them to be able to get access to your data. So you would do that by encrypting your data at rest and by using sort of secure encrypted protocols for communications between your systems running within AWS. That's best practice.
Yeah, so the default would be when I created that database in AWS, HMRC customer data, so we don't quite do this, but if it did, then by default it would be encrypted. And it would be encrypted with a key that we have and we need to manage. But again, if I gave it away, then somebody could come in and take my data. So AWS are giving me a mechanism to protect my data, which is encryption. But encryption, it's a bit like you giving your password away.
Now, I was thinking more in terms of if you've got data that's held, I don't know how much about this side at all, but if we sell data or systems on one server in one physical location in the country, and if that went,
yes, then it would be available
elsewhere.
That's if you chose to put your data in two locations. That's right.
So I wouldn't have thought that as a user you'd have to think about that. I wouldn't have thought that would have been up to them to say, well, we're going to keep your data in different places.
No, because for your development environment, you might say, actually, I'm going to turn it off at night, and I don't want it in two places. It's just not worth it. If I lose it, just look, I don't want to pay more money for having it in two places, whereas for production you might. So you do still have to make that choice.
It's like everything else, you need to stipulate the non-functional requirements associated with the infrastructure. And part of that non-functional would be to stipulate I want to share my data somewhere else.
Yes, okay.
You know, and you, once you've stipulated it, you can put the rules around it in the same way as the rules.
Thank you.
2 minutes? 2 minutes, okay. Very quickly crack on then. So we talked about this infrastructure as code. You've probably heard the term DevOps. AWS very much lends itself towards this sort of new DevOps culture. So the ability to sort of empower development staff to be able to deploy applications and products to the internet and to do it quickly and to do it continuously. So we'll go through the individual tools. So there's a whole bunch of sort of common tools.
In a couple of weeks, we're going to have a session on that, as James Managed to do. So,
So
mentioning Terraform and things like that would be useful.
Yeah, so Terraform is sort of one of the sort of main tools that is used to orchestrate, so deliver. So from code, you write it in Terraform. Terraform being effectively the language, if you like. And that can then build up in AWS whatever you want it to do, however many instances you want deployed, etc., which services it really can control every element of it, including
so what Jamie just did in that console, I want a server of this form, with this operating system on it, connected in this way. Terraform, you can basically write a program to do that, and then just say, please execute my program, and that infrastructure will be configured as described. So it's a programming language for describing infrastructure.
So yeah, Terraform, Puppet, Chef, and Ansible perform a similar function, and again, you can use these to deploy on AWS or Azure and others. Code is stored in things like GitHub and Bitbucket. Tools like Jenkins and Bamboo are used to sort of control pipelines, so moving code through various different phases, transforming information, running jobs, etc. AWS provide a number of tools which sort of emulate some of these tools up here. that you could use as well. Containers, I probably won't go into that's a rabbit hole.
Later weeks.
But obviously through code, making sure everything's highly available and scalable, and again, probably tackle Lambda and serverless in a different session. But that's probably it.
Good. Questions? That sounds sensible.
So it's quite
possibly easy to understand or difficult to understand?
Yeah, that's good. We ran something into press over the weekend. It was something about CERN who actually reaching out to people to loan out capacity on their own computers. It feels almost a bit of a reverse of cloud. Have you heard of that?
Yes, we've been going on for a while. IBM pioneered grid computing, so you can send a small workload to a particular. There was a screensaver SETI at home quite a few years back where they sent you some data from radio telescopes, and you could search for aliens whilst your screensaver was running. And also, I think there's been a number of those engines can be used for all sorts of jobs. But there's another one that I sort of participated in, which was a cure for cancer, running all the different sort of protein analysis. So whilst your computer's on screensaver, instead of mining Bitcoin, you can use it to find aliens or cure for cancer.
Yeah. What would you say what's the one big thing that's going to change in this space over the course of the next year or two? What's the sort of big?
Adoption is rising hugely. Containers are already on the rise. The big theme from reInvent, which was the AWS conference from last year, is about sort of changing the interfaces that you use to interact with computers instead of a keyboard and a mouse. Some of you might have an Echo Dot at home. The tools that AWS used to build that are available in AWS for you to use as well. So you could build applications that make use of sort of voice transcribing and also some AI capability as well.
Yeah, how does he think the voice interface will become the default interface now? That seems to be there. We'll talk to it.
But we're coming from a culture where they've obviously got a lot of infrastructure that still sits on virtual machines. On physical machines, and obviously the ambition is to move on to virtual, but we seem to have a lot of blockers still from a technological perspective, in that the old applications themselves just don't lend themselves to these environments. You talk very well and good, that you keep embellishing, if you like, the new wave of stuff, if you like. But I think there's some help needed around all of the older stuff and how we move that forward. I suppose that's something we're very aware of. We always need some miracles in that space.
Yeah. So on a cloud provider, you can generally get a couple of versions of Windows. But I know that for Windows it goes back quite a way.
Yeah.
But if you've got really, as you're pointing out, you've got really old applications running on Windows NT or Windows from many years ago, it's unlikely that you'll get a cloud provider that's going to provide you that infrastructure. Having said that, they do recognise this legacy transformation issue, and they are providing different mechanisms. So containers, we haven't got time to go into it today, but containerization is a way of building older infrastructures that can take older applications. But you're right, in general terms, cloud providers will give you up-to-date operating systems, which for people like HMRC is a real issue because they've got really old stuff. And therefore it isn't an easy transition, as you've said. But recognised as a big problem, and they are beginning to help, but it's not straightforward.
There's another challenge that we're going to face, which is the commercials. Simply around if HMRC deliver a group want to stand up platform as a service, but we've got the application on top, how do we then charge for that application? We don't have
absolutely. This is why clouds are sort of fundamental shift for everybody. Finance people need to start understanding cost models for cloud. Because it's a different game, I would say.
It's also going with the licensing thing as well.
Yeah.
I'm sure that the licensing model for all applications and whatever you were based on CPU usage.
Yeah, absolutely.
Completely new level playing field.
Yeah, I think some vendors are actually deliberately muddying the waters. I know AWS had a beef with a certain red-coloured database provider.
Yeah.
But
Not particularly bad. Right, that's the end of our time. That was very good. Thank you, Jamie. You got through with your cold, which is really good. Thank you very much.
thanks everyone.
Thank you.
Thanks a lot.
You ever see a day when all these big providers get hacked?
Yeah, well, I mean, they were all susceptible to Meltdown and Spectre up until, although supposedly the news came through sort of in September, October time. And
So if you-
certainly
if you want
AWS
to,
were
like,
working on it,
try and
so last year,
like,
vulnerability was always there.
And let's say you're like, I don't know, some company and your website go viral.
More reason to make sure that
So the cloud
your own environment you are
then automatically expands what you've got.
You do your own security, but
So automatically,
it's
And then they bill you for that expansion.
Yeah, so what we put,
Thanks,
Jamie.
thanks, Andy. If you're running a website, a
It's
simple
always
web
that
service
nervousness
like
about, you know, so what is it,
common open source
vulnerabilities
website,
in
Yeah.
the actual the
you
AWS
could
space.
say to AWS, I want to start with one web server,
Yeah, I mean,
and I want
they're
you
using
to
basically
send it a
modified
message
version
every
of,
few seconds, and if it gets slower, so when I send it this health check,
you can,
are
if
you
you want to,
okay, are you
run
okay,
bare metal
oh,
on
you slowed down,
AWS with
then
costs.
you can configure something that says start me another one.
That might mitigate some of the
So
sort of
that's something
multi-tenancy.
So that's called, probably
Not everything.
I'm guessing these guys have probably got
Yeah,
things
yeah,
brains
yeah,
and
yeah,
working
yeah,
on
and you
protecting
can,
this
you
stuff as
can
well,
have
haven't
them
they? So
and take it away, and that's what load balancing is in this.
very interesting.
Yeah.
Really good. Yes,
Basically,
thank you.
by asking them
Yeah.
how busy they are, since they start to look and simulation of them.
Yeah.
And also
Cheers, take
scale
care.
that machine. I say, you know, I only want to stick the whole machine, but I
Oh,
want to make that.
is this yours?
bigger.
Yeah.
Yeah, so
Maybe
maybe
before we sit on it before, thank you.
That's all.
CPUs or whatever, yeah.
That's all open to you, but you have to configure that. It's not magic.
Right.
So you have to put in some intelligent load balancing that says, I've got one server, when it's under load, I'd like to start another one. But
Right.
the option
So
starts
I'm
with
just thinking, if for example, like if you've got like some company and like a small company and it just went viral overnight,
Yeah.
but you only had like a small machine,
Yeah.
so it would just crash, or it would throttle, or what would
well, generally it would probably crash.
probably crash. So it would just crash unless it had some software written to horizontally or vertically.
Yeah, but they
increase
provide
the-
that for you. You just need to configure it in that way to say,
Yeah.
if this machine ever comes under load,
Right.
add more machines.
So you've got, you'll
But then I
have,
suppose the flip of that is if you didn't have the cash flow to meet the
Yeah, but it will only get used if the load comes through.
yeah. But then if the load comes through, but you can't afford to pay for it,
Ah, well, in that case,
you can set limits.
that's
yeah,
another
you can
thing.
set
Yeah.
limits as well,
Do you
absolutely.
know what I mean? Yeah. Oh, right. Interesting. No, that's my only query really, because obviously, from being a arms project manager,
Yeah.
here, okay, so it grows and shrinks, don't need to worry about it kind of thing, but you do. There is still a lot of intelligence on how it grows and shrinks. So.
Yes, sure. Yeah. People still need to know how to do that. It's not
Yeah.
done for you automatically, but it's made straightforward for you.
Made a lot.
It's made a lot easier,
It's
but it's not
facilitated, but
Yeah.
you still need to do as an architect the groundwork to do that.
Yeah.
Cool.
Good. Thank you very much.
Thank you.
Well done.
Sorry, guys, it's just had a meltdown.
Don't worry about it. You did well to get through it, mate. Our double act seemed to work, didn't it?
Yes.
Yeah, I know it's like when you got a cold and you just full of it. It's horrendous. Thank you very much.
I just woke myself up, I think. Sorry about that.
No, it's fine. Don't worry.
I'll practice.
It went well. I think it's good. Good content.
Got most of the way through.
Do you need to shut this down?
Yes, you can terminate it for me. Instant state.
Oh, yes, yeah. Oh, yeah.
So you usually use the CLI.
I do, yes. Terminate.
Yeah. Yes, thank you. Yeah.
Yes, I don't use the console very often.
No, I only use it for looking at CloudWatch.
Do you?
Yeah, most of the time.
No, that's good. That's quite a neat little feature, isn't it? Is that your own?
Yes.
Just not in there?
Yeah.
Yeah, perfect. Good. Let me stop the recording.